Hello. So welcome to, I believe this is Friday's lesson. Go ahead and get your book out. We're gonna go ahead and turn to page 60. So if you guys missed me, by this time it'll be Friday. Have a good day, guys. Make sure you guys are being very consistent in your work. We miss you, we love you. So I'll go ahead and get started with the lesson. So we're gonna learn about proportionality theorems. We're gonna do just 2 today. There's 4 in the book, but we're gonna just go according to the worksheet. It says Friday, March 20th, so it looks like this, and it looks like this. The best part about these worksheet is if you need further explanation, there's all of this up here and back here to help you out and guide you. So again, make sure you're reading. Don't just look at it and say, oh, I'm done. I can't do it anymore. Keep on going. Lesson 60, proportionality theorems. According to this, there are 2 types of theorems. Dash 1. There is the one with the triangle, so the one we're gonna learn today. Basically what they're saying is A, X, Y, B, and Z. They said that the first part here, XA, is proportional to the second part here. So it's the first part, this whole fraction part, we're dealing with proportionals. And the first part of this fraction is always going to be one side of the triangle. So this is XA, and this is going to be AY. Next one is going to be XB and BZ. So it's one part compared to the other part of the triangle. Example 1. A, we're finding one of the lengths. We have a triangle like this. It looks like we have 2 lines here. We have A, D, B, C, and E. According to this is 2, this is 3, this is 5. So we are trying to find this measurement here. We're going to label that X. We are trying to find the measurement of that. So example 1 in the theorem states that if a line is parallel to one of the sides of the triangle. So again, this is different from the midpoint, the midline, midsection, because it's not exactly in the middle. We don't know if it's in the middle, but we do know that these lines are parallel. So here, these arrows are telling us these lines are parallel. If they are parallel, we are able to find the measurement of the small one side here. So we create proportions. So line, equal sign, line. So for proportions, it's always one side. You're comparing one side to the other. So if I write the first side in my proportion, I'll have the first part, which is 2 over 3, and set it equal to the first part of the second line where they meet, which is X over 5. Next step, you go ahead and cross multiply. So let's see if you can see it there. Yeah, you can see it. So 2 times 5 equals 3 times X. That's what cross multiplication is. So once you do that, you have 10 equals 3X, get the X by itself, and you get X is equal to 10 over 3. You don't have a perfect number, so therefore you just leave it like that. Second one is you're finding B. So we have a shape. Again, it's similar. So it looks like this. There's a line here. This is X plus 1. This is X plus 3. Here is 5. And this is 10. So I'm not writing all the numbers because in proportions, we're just dealing with just these numbers right here, nothing with any of the letters. They have in the book, they further explain this. They first write this out and then they write the numbers in place of it. You don't have to save time. For this, we are writing proportions. According to the directions or in the instructions, we have arrows. So the arrows signify that they are parallel. If they are parallel, we can go ahead and use this theorem, meaning one side is proportional to the other side. So one side is, we're gonna deal with the top to the bottom, X plus 1 over 5, which is equal to, compared to the other side, is X plus 3 over 10. Next step, cross multiply. 5 times, start the first way, 10 times X plus 1 is equal to 5 times X plus 3. And then from then on, you solve. 10x plus 10 equals 5x plus 15. Try to get the x by itself. I'm going to go ahead and move this over. At the same time, while moving it over, I'm going to move this 10 over here. Why? We're doing multi-step equations. But at this point, you should know how to do multi-step equations. You should get the x by itself. Go step by step if you don't know how. And your x is equal to 1. So again, step by step to figuring out if it's proportional or not. I have room here. Okay, example 2. So this is A and B. Example 2, here it says to prove that these are congruent. So we have a line here, we have a line here. This is 3, this is 8, this is 2, and this is 7. To prove that they are congruent, this we use proportions to solve for missing sides, but proportion means that one side is equal to the other side. So let's go ahead and create proportions. So the first proportion I'm going to have is 3 over 8. So I'm going to start this way, going that way. You could do 8 over 3, just make sure you go the same method, same direction when you're writing these down. So I'm just doing 3 over 8, so from left to right for one line. And for my other side, I'm going left to right again, so 2 over 7. According to this, equal sign meaning that they are equal. Go ahead and cross multiply. You should have the same answer for both sides if they are proportional. So then you have 3 times 7 is equal to 8 times 2, and that is 21 equals 16. They're asking us, are they proportional? No, they are not. They are not proportional because numbers do not match up. Math, everything always matches up. Last theorem, I almost tripped there. 60-3. Lines over lines over lines. I like geometry because it's a lot of shapes. Get used to the shapes. According to this, we have, let's say this is A, this corner is A. Let's say this corner is C, this is E, this is B, D, and F. According to this theorem, we have one side, again, we're not dealing with triangles, but we are dealing with sides. So if these lines are all parallel, that means you can create proportionals. So that means the first side, AC, is proportional to CE. So again, they are from the same line, that's what your fraction is proportional or is equal to the other side, which is BD and DF. And from this equation, you can go ahead and solve the rest of your worksheets, which is the back part is dealing all with this, but you could do that on your own. Just make sure you read the instructions, but it's just understanding you're creating proportions, whether it's lines or it's triangles of any sort. So I love you guys. See you later.